Welcome to question 5, the Applied Marks Statistical Department. Right, so we've got A and B are mutually exclusive. That means they do not touch. You can see that one. Independence you cannot see from a Venn, but mutual exclusivity you can. Probability is not equal to 0, so probability A, you got A is 3 times that of B. Or should we make that B then? And this A is bigger. A, B, so A is bigger. Draw a Venn diagram to illustrate possible values of B. So, well, okay, I guess to B is to B equals P, which is 0, so it's got to be bigger than 0. Let's say outside, if this is 0, then you're going to have probability of B plus probability of A is equal to 1. So that's probability of B plus probability of B is equal to 1. So that's 4. Probability of B is equal to 1. So probability of B is equal to 0.25. So that's the biggest it can be. There we go. As such, so what have we got here? Should we go up here? Can we see up here? Well, it's very confusing lettering on this question, isn't it? Oh no, maybe not. Maybe it is though. So the second part, anyway, this bit, C and D. So it's going to be this part. Go down here. Probability of C given D is equal to 3 times the probability of C. Probability of C does not equal to 0. Explain whether C and D could be independent. No, not independent. Because one of the definitions of independence is C given D is equal to probability of independent. This is 3. So give C. Right, this down. Probability. So C and D is equal to half probability of C. What else do we got? Probability of C naught and D naught is equal to 7 over 10. Find C. I'm going to draw this as a Venn diagram. Let's have a look. What about C? They're not independent. We don't know about their exclusivity. I'm going to assume there's some sort of intersection. Not C and not D is 7 over 10. So that's that region outside, isn't it? Okay. D, let's call that C and D, is equal to a half C. So we've got C and D, call that X, is equal to half of the whole thing. Okay. So this is going to be, so if we call that Y, 7 marks, let's have a look. So we know X is equal to half X, Y. What else do we know? So that's the probability of C and D equal to a half the probability of D. The whole thing, X and Y. No. Probability of C and D. Know that. Yeah, is 3 times the probability of C. So how can we use that? Probability of C given D is equal to probability of C and D over probability of D So what's that in terms of our x? So find those probability of C equals C and D. Probability of D. That's just going to give us one equation. Is going to be is that bit in there. We can get in terms of x and y, can't we? Yeah, because it's going to be 1 take away 0.7 take away x take away y, which is 0.3 take away x take away y, 0.3 take away y. Okay, now we're going to have two x and y. Hopefully we can then solve them simultaneously. Through 3x plus y is equal to c and dx over, God, that's not very nice though, is that? Is there another equation we could use? This, yeah, okay. We know from this one, we know that 2 is equal to x, y. So we can replace x plus y with 2x. So 3 is 2x to x over 3. Well, this is just minus x plus y, isn't it? X plus y. Hey, a minute now. So 6x equal to over 0. Minus x plus y is 2x. Hurrah. We get 6 times 0, 3, 2x is equal to x. So from that we 12x squared, x times 3 plus 1.8x equals x. We can use that. What are we looking for? Probability of C. So we're going to need y in a second as well. Fine. Okay. X into minus 12 plus 0.8 is equal to 0. So x over equal to, in which case we get y equals 0. So that's BS. Or we get 12x is equal to 0.8. So x is equal to 0.8 divided by 12, 1 over 15. So then what's y equal to? So we get go. So when the photo comes clearer. So y. So here from this actually we get x is equal to, oh, should have seen that earlier. So y is equal to 1 over 15. So we get probability of C is equal to 15. That's right. Is not right. Where have I gone? Okay, so we know this is true. So if we go in here, we get 3PC is equal to PC B, and that cancels with B equal to 6. All of this, but that region there, B over 10, take away 2 over 15. So that's 2 over 15, and then we know equal to that. So extra half here. There should have been extra half kicking around here, which follows through. So yeah, and so that's so yeah, where was that? Would have been so half down. Yeah. So anyway, there you go. So that's 2 over. Oh, so that's going to be 2 over 15. And we get 4 over 15. This should have been a 6. And we chased it all the way back. Okay, great. There you go.